This is the Year 12 Maths Methods VCAA VCE 2017 Exam 2 Extended Response Section, Section B, Question 4. Question 4, let f, where the domain is R, where f equals 2 to the power of x plus 1 minus 2. Part of the graph of f is shown below. You can see there's a horizontal asymptote at y equals -2. And clearly it's a exponential graph. Part A, the transformation t is equal to x on y plus cd. Maps the graph of y equal to 2 to the power of x onto the graph of f. State the values of c and d. Here they're talking about how do you go from y equals 2 to the power of x to f equals 2 to the power of x plus 1 minus 2. Well, one way to answer this question is to go like this. Going from left to right, we gradually change y equals 2 to the power x to f equals 2 to the power of x plus 1 minus 2. So you start off with the graph y equals 2 to the power of x, which has got a horizontal asymptote on the x-axis, and the curve goes through y equals 1, which we can call point A. Then, going from left to right, the next difference that we see as we go from left to right is what? Well, we got y is the same, equals 2 to the power x plus 1 within brackets. Next difference is plus 1 within red brackets. What effect does that do? Well, every time something is within brackets, you do the opposite. So because plus 1 is within brackets, you do the opposite. What's the opposite to plus 1? Minus 1. And because the 1 is next door to x and x is the horizontal axis, then you draw a horizontal line, and do you move the whole graph that way or that way? Well, because it's minus 1, you move the whole graph in a negative direction. So you move the whole graph in a negative direction. So when you move, you move the whole graph in a negative 1 direction. So when you move that point A 1 to the left, you're going to have point A being there at x equals -1. So that's the graph of y equals 2 to the power x plus 1. Then as we go from left to right, the next difference that we see between y equals 2 to the power of x plus 1 and y equals 2 to the power of x plus 1 minus 2 is the minus 2. So we put in the red minus 2. Now, because that red minus 2 is tagged at the end and that red minus 2 is not within brackets, you do what it tells you to do. You just move the whole graph down by minus 2. So you move the whole graph down by minus 2 in the y direction. And when you move point A minus 2 units down, then y equals 1 minus 2 goes to y equals -1. So point A going down 2 units goes to here. And of course, you move the horizontal asymptote 2 units down to y equals -2. And you achieve the graph of f equals 2 to the power x plus 1 minus 2. So, having determined the changes, now we can answer the question. The transformation is equal to x plus y plus cd. So, transformation equals x on y plus C is in the x direction minus 1, and D is in the y direction is minus 2. So therefore, C equals -1 and D equals -2. So we've answered part A. Now we go to part B. What is part B about? Question D says the following. Find the rule and domain for the inverse function f, the inverse function of f. From the graph shown in the exam paper here, we can see that f is equal to 2 to the power of x minus 2. The domain is real numbers, and we can see clearly that the range is y greater than -2. Now, as you should know, to find the inverse, we need to interchange all the x and y's. So therefore, wherever you see a y, you put an x. Wherever you see an x, you put a y. And then wherever you see an x, you put a y. And wherever you see a y, you put an x. That is, when we say to you that to find the inverse, you got to interchange all the x and y's, we mean you got to interchange all the x and y's. Then you got to get y by itself. One way to get y by itself is to use the solve function on the CAS calculator and say to the CAS calculator to get y. The other way of getting y by itself is by hand. And just to give us a little bit more practice, just in case it appears, just in case a similar question appears in exam 1 where you can't use any CAS calculator, let's get y by itself by hand. So to get y by itself, we put that minus 2 on the other side. X plus 2 equals 2 to the power of y plus 1. And then to get rid of that base, then to get y by itself, we've got to get rid of that base 2. How do you get rid of that base 2? You get rid of that base 2 by using the fact that the opposite of base 2 is log 2, and in maths, opposites cancel out. So I rewrote that black writing again down here, and I put a red log 2 on that side, and it's the old story. You can do whatever you like on one side, as long as you do it on the other side. So you put a red log 2 on the other side. And then because of what I just said, because the opposite of base 2 is log 2, and because in maths opposites cancel out, then that base 2 cancels out with its opposite log 2, and you're left with log 2 x plus 2 is equal to that base 2 cancels out with its opposite log 2 and left with y plus 1. And then you put the plus 1 on the other side, and you got y by itself. So therefore, y equals log 2 x plus 2 minus 1. And that's the inverse function. Therefore, inverse function equals log 2 x plus 2 minus 1. And the domain of the inverse function will be, x greater than -2. And if you want to write out in the same way as they write out the rule in the exam paper question, it would become the following, that the inverse function will have a domain between -2 and infinity mapped onto R, and the inverse function is equal to log 2 x plus 2 minus 1. And by doing that, we would have done part B. Now we go to part C. What is part C about? Part C. Find the area bounded by the graphs of F and F inverse. That is, they want us to find the area between the F graph and the inverse F graph, which is that green shaded area here. How do you find that green shaded area there? Well, by using calculus. And by working out the coordinates of the intersection points between the F curve and the inverse F curve, which are here and here. So therefore, as part of the worked out solution that will give us the area of this green shaded area, we need to work out the intersection point here, x1, y1. Well, the green shaded area using calculus equals the integral of the top curve minus the bottom curve. And that's equal to the integral of that x intersection point there, which is x1, to that x intersection point there, which is x2, top curve. The top curve is the F inverse curve, which is log 2 x plus 2 minus 1 minus the bottom curve. Pretty much every time when you see minus, to reduce the chances of making an error, put in open brackets. Bottom curve, the bottom curve is the F curve, which is 2 to the power of x plus 1 minus 2, close brackets dx. Clean that up a little bit. That's equal to the integral of log 2 x plus 2 minus 1, negative times everything inside the brackets, which is negative 2 to the power of x plus 1, negative times negative 2 is positive 2 dx. And then you can further clean that up by saying integral of log 2 x plus 2, negative 2 plus 2 is 1, minus 2 to the power of x plus 1, and that's where we add in the overall calculation 1. Now, the thing is, to fully work out this integration, we're going to work out what is x1 and what is x2. That is, we're going to work out where is that intersection point there and where is that intersection point there. That intersection point there seems to be at the origin. To be 100% certain about where these two intersection points are, we're going to do a little bit of side calculation. So we're going to now do a little bit of side calculation, and at which point we'll go back to this over calculation 1 again. So how do you find that intersection point there and that intersection point there? Well, the thing is this, like I say here in red, to find these two intersection points here, we've got to realize that when we are dealing with inverses, it is always the case that the original function and the inverse function and the line y equals x all intersect at the same point. So by using that, we can somewhat simplify our calculations by saying that we can find these two intersection points by making function f equal to y. And that is function f, which is 2 to the power x plus 1 minus 2 is equal to y is x. At which point we can work out what x is by using the solve function on the CAS calculator, and we get x equals -1 and x equals 0. That is, x1 is -1 and x2 is 0. At which point we can go back to the overall calculation 1, which was over here, And we saw earlier on that the green shaded area is equal to the integral of log 2 x plus 2 minus 2 to the power of x plus 1 between x1 and x2. So therefore, what's x1? We just discovered that x1 is -1. And what's x2? x2 is 0. Now we go to the next part in this sub-question. So at which point we can work out this integral quite easily using the integration function on the CAS calculator, and the CAS calculator will give us this. Now, like I say here in red, this answer is okay. And in my opinion, if you leave it like that, it should be okay, in my opinion. But when you got some doubts about whether or not you're going to continue on, one question that you can ask yourself is this. Is there a way in which we can write this out so that requires less ink? And if the answer is yes, then it's a good idea to continue on so you can write the final answer in a way that requires less ink. And that's what you can say about this. Now, firstly, that answer is correct. But like I say here, this answer is okay. To get the answer shown in the exam report, we need to do the following. Firstly, using the log law that says log base AB is equal to 1 on log base BA. That is, you can interchange these two numbers as long as you put them 1 on. We can say the following. -2 times, you interchange the 2e to log e2, 1, minus 3. And then you say, well, of course, 2 times 1 on log e2 is 2 on log e2. Then you say negative times everything inside the brackets, and you get -2 log e2 plus negative times -3 is plus 3. Now, and that's the answer given in the exam report. And you should get 4 marks for that, of course. Now, at which point, based on what I was saying before, if in the exam you got some doubts about whether or not you're going to continue on with this, then like I was saying to you before, one way that you can dispel much of those doubts is to normally take this path. You can ask yourself this question here. Is there a way in which I can write this out so that it requires less ink? And the answer is yes. How? Well, you put the plus 3 at the front, and it ends up being plus 3 minus 2 log e2, and then you can drop out the plus in front of 3, and it comes out to 3 minus 2 log e2, and that does require even less ink. And because it requires less ink, then it's a good idea to take that extra step, just to be sure. And that's the end of that sub-question there. Now we go to the next question. The next sub-question is part D. Now, what is part D about? Part of the graphs of F and F inverse are shown below. All right? We've just seen this graph. That's the F graph with the horizontal asymptote at y=2. That's the F inverse graph with a vertical asymptote at x=2. Find the gradient of F and the gradient of F inverse at x = 0. Well, you can work out this question mostly by using the CAS calculator. So find the gradient of f curve and the inverse of f curve at x equals 0. First, find the gradient of f at x equals 0. That is, first find, what's the fancy way of saying gradient of f? Is say f dash x. So therefore, first find f dash x at x equals 0 by using the CAS calculator, using specifically derivative at a point function on the TI Inspire. You select menu, select for calculus, select to derivative at a point. A pop-up box appears. Make sure the variable says x. Put the value of 0 because they're saying find the gradient of f at x equals 0. And of course, select first derivative and press OK. And at which point, because we got to work out the gradient of f equal to 2 power of x plus 1 minus 2, you type in the following. You will see that the CAS calculator will give you d dx. Type in 2 to the power of x plus 1 minus 2, and the CAS calculator will automatically give you a vertical line, x equals 0. Press enter, and the answer will be 2 ln 2, or in other words, 2 log e 2. And that's the answer shown in the exam report. Now we've got to find the f dash x at x equals 0 for the other one, for f inverse. By again using derivative at a point function on the TI Inspire, we achieve the following. Since it's the inverse of f, then which is equal to log e base 2 x plus 2 minus 1, then type into the calculator log 2 brackets x plus 2 minus 1, and when you hit enter, the calculator will give you log base 2e. Now again, to get the answer mentioned in the exam report, do the following. Because you see, if you, the CAS calculator gives you that answer there, that should be all right. If you leave it like that, they should give you full marks. But if you're curious about how you get the answer shown in the exam report, you go like this. Log base 2e on 2 is equal to a half times log base 2e, and that's equal to a half times, like we said before, there's that log law that says if you interchange these two numbers, that's okay as long as you put them one on. So 2e goes to e2, and then using basically grade 5 fraction theory, a half times 1 on log e2 becomes 1 on 2 log e2, and that is the answer given in the exam report. And that's it. That's the end of that question there. But I want to emphasize this important point, which I know that quite a number of Year 12 maths method students are a bit unclear on. It must be clear in our minds that, yes, the derivative of e to the power x is e to the power x. That's true. That is, the derivative of 2.718 basically to the power of x is equal to 2.718 to the power x. But the derivative of 2 to the power x is not equal to 2 to the power x. All right? The only case where they are equal is when the base is equal to 2.718. All right? So please note that down, just in case a question appears where you need to know this red section here. Now we go to the next subsection. which is subsection E. Now, what is subsection E about? What is subsection E about? The functions of GK, where K is an element of positive real numbers, are defined with domain R, such that G subscript K is equal to 2e to the power of kx minus 2. E. Find the value of K such that G subscript K x equals fx. Part E. Part E. They're saying to you basically from the information they give you that G subscript K is equal to 2e to the power of kx, where according to the question, K is an element of positive real numbers, minus 2. Now, they tell you that X is an element of R. From that, they're asking you this. Find K for G subscript K equal to F. Now, G subscript K is equal to 2e to the power of kx minus 2, according to the question. And that's equal to F, which according to the question we saw was equal to 2 to the power x plus 1 minus 2. From that, they want you to find K. Well, you can find K by using the solve function on the CAS calculator. So you just go to your humble solve function on the CAS calculator, type in all of that, which I did in black here, and put in comma K to tell the CAS calculator, okay, CAS calculator, find me what K is, then press enter, and the CAS calculator will give you K equals ln2. That is, K equals log base E2. And that's the end of part B. Now we go to part F. Now, part F says the following. Find the rule for the inverse function G subject K inverse function of G subject K where K is an element of positive numbers. Well, in part F, they want you to find basically the inverse of G subject K. Well, as you should know by now, there's two ways of finding the inverse. The first way of finding the inverse is to do it by hand. And because, like I was saying to you earlier on, it could be the case that in exam 1, they might want you to find the inverse of some function, and you can't use a CAS calculator in exam 1. It's pretty good. It's a pretty good idea to have a bit of practice by hand in regards to getting y by itself and all that. So therefore, method 1, find the inverse by hand. G subject K equals 2e to the power kx minus 2. Like we were saying before, interchange all the x and y. Wherever there's a y, you put an x. Wherever there's an x, you put a y. And then, like we were saying before, find y. That is, get y by itself. Okay, put the negative 2 on the other side, plus 2. And then divide by 2. And then to get rid of that base E, like we were saying before, to get rid of that base E, you go like this. What's the opposite of base E? The opposite of base E is log E. And in maths, opposites cancel out. So I rewrote all that black writing over here. And to get y by itself, you've got to get rid of that base E. How? By going like this. What's the opposite base C? The opposite base C is log E. Whatever you do on one side, you do on the other side. And then in maths, opposites cancel out. So that base C cancels out with its opposite, log E. And you're left with log E, x plus 2 on 2 is equal to, that base C cancels out with its opposite, log E, and it's ky. And then get y by itself by getting rid of that times k. What's the opposite times k? Divide by k. And then in maths, opposites cancel out, like what we've been saying. So that divide by k, that times k, cancels out with opposite, divide by k, and left with that. And that is y by itself, and that's the inverse function. So y equals 1 on k. 1 on k is equal to log E, x plus 2 on 2. So therefore, the inverse function is equal to 1 on k log E, x plus 2 on 2. Well, the second way of finding the inverse is to use the solve function of the CAS calculator, which goes like this. G sub k is equal to 2 e to the power kx minus 2. Interchange all the x and y's. And so wherever you see a y, you put an x, and wherever there's an x, you put a y. Then we got to get y by itself by using the CAS calculator to solve for y. And the CAS calculator will give you that, which will be inverse function g is equal to 1 on k log E x plus 2 on 2. And that's the end of part F. Now we go to part G. What is part G all about? Part G is about the following. G part 1. Describe the transformation that maps the graph of G subject 1 onto the graph of G subject k. So they're telling us what transformations you have to do to G subject 1 to go to G subject k. Or in other words, they're telling us what change you have to do to G subject 1 graph to get G subject k graph. Well, to work out that, we're going to take the following approach. Firstly, they tell us in the question that G subject k is equal to 2e to the power of kx minus 2. They're talking about G subject 1. So k equals 1. So you put k to 1, you put k to 1. So G subject 1 is equal to 2e to the power of x minus 2. So therefore, when you look at it in the final analysis, because G subject 1 is equal to 2e to the power x minus 2, in the final analysis, the question wants you to find the following. What changes or what transformations you have to do to G subject 1, which is equal to 2e to the power x minus 2, to go to gk, which is equal to 2e to the power of kx minus 2. Well, to work out that, we've got to realise this, that here, the only difference between the G1 graph and the GK graph is basically that the G1 graph's got nothing, so to say, in front of x. It's got a 1, of course, while the G subject k graph's got a k in front of x. And everything else is the same. So it seems as if the answer to our question will deal with the k. Also, we need to understand that those two 2's are in front of everything on the right-hand side of the equation. And as we saw, the two 2's will make the graph go up or down. In this case, will result in us multiplying the y on x by 2. So the graph will go up vertically up. Also, these two equations got to take at the end minus 2 at the end. Now, because the minus 2 is taken at the end, and it's not in brackets, then you do what it tells you to do. You just drop the whole graph down by minus 2. So therefore, you vertically move the graph down. So therefore, that 2 and that negative 2 makes the graph go vertically up or down. While that k, because the k is only in front of x, then every time the k is only in front of x, you have to divide the x values by k. And when you divide the x values by k, you move the graph horizontally. So therefore, the k will influence the horizontal and the k will not influence the vertical. So because the k, which is the only difference between this one and that one, only influences the horizontal and does not influence the vertical, and that's another reason why you just consider the k. So, and I went over that in detail because in past exam paper questions, students have not had a clear idea about when there will be transformations occurring in the vertical and when the transformations will be occurring in the horizontal. Now, with this question here, like I've been saying, and I say here in red, because the only difference between the G1 graph and the G sub k graph is that there is a k in front of x, then to go from the G1 graph to the GK graph, we need to divide the x values by k. That is, work out x values divided by k. That is, using grade 5 fraction theory, you keep the first, when you got a fraction, so to say, divided by a fraction, so to say, you keep the first fraction the same, change that divide to times, upside down the second fraction. So therefore, it ends up being x values times 1 on k. That is, you multiply the x values by 1 on k. And in maths, every time you multiply the x values by a certain number, what are you performing? You're performing sorry, I had something in my throat. You are performing a dilation. So here you end up saying dilation by a factor of 1 on k in the x direction. And that's the answer to that sub-question there. Now we go to the next sub-question. The next sub-question is G part 2. G part 2 says the following. Describe the transformation that maps the graph of G1 inverse onto the graph of G sub k inverse. How do you do such a question? Well, the question wants you to find the transformation that you're going to do to G1 inverse, so to get to GK inverse. We have that the G1 inverse K from our earlier calculations was 1 on K log E x plus 2 on 2. And they're talking about G1 inverse. So we're going to work out G sub 1 inverse by putting K equals 1. By putting K equals 1, and you end up with G1 inverse equals log E x plus 2 on 2. So therefore, the question wants you to find the following. G1 inverse equals log E x plus 2 on 2. How do you go from G1 inverse to GK inverse. That is, the question wants you to find the change that you got to do the G1 inverse to get it to GK inverse. How do you find that change? Well, like I say here in red, because the only difference between G1 inverse and GK inverse is that there is a 1 on K in front of everything on the right-hand side of the equation, then to go from G1 inverse to GK inverse, we need to multiply the Y values by 1 on K. That is Y values times 1 on K. That is, every time you multiply the Y values by a certain number, what are you performing? A dilation. So here we are performing a dilation by a factor of 1 on K in the Y direction. And by doing that, we've answered question 4G part 2. But here we got a interesting result that might come in handy in the coming up exams, and it's this. And I've stated here in red here under this note. No, this is not a surprising result, because when we found the when we find the inverse, we interchange all the x and y's. What do I mean by that? Well, look at the following result that we got. In question 4G part 1, the answer was dilation by a factor of 1 on K in the x direction. And then in the next sub-question, in question 4G part 2, where we were dealing with the inverse, then unsurprisingly, the answer was dilation by a factor of 1 on K in the y direction. So we're going back to something that you should know quite well by now, that when you want to find the inverse, you've got to interchange the x and y's. And because this second sub-question dealt with the inverse, it's not surprising that the final answer was simply obtained by interchanging the x and y's. So that's something to keep at the back of your mind. You never know if it's going to pop up in the coming up exams. That when you're dealing with the inverse, you just interchange the x and y's. Because as you can see, the only difference between the answer that we got between 4G part 1 and 4G part 2 is that that's an x and that's a y. That is, to find the inverse, we interchange the x and the y. Now we move on to the next question. The next question is question 4H. Question 4H says the following. The lines L1 and L subject 2 are the tangents at the origin to the graphs of G subject K and G subject K inverse function, respectively. Find the values of K for which the angle between L subject 1 and L subject 2 is 30 degrees. What are they talking about? Well, one good way to demystify and simplify this question is to basically graph it. So what you can do is the following. You can get a rough sketch of what they're talking about, and from that rough sketch, it's going to make it a little bit easier to answer the question. How do you do that? Well, by taking, for example, the following approach. Sketch the graph of G subject K equal to 2e to the power of kx minus 2. We can have a good rough idea of G subject K equal to 2e to the power of kx minus 2 by putting K equals 1 and obtaining G subject 1 equals 2e to the power of 1x minus 2. That is, G subject 1 x is equal to 2e to the power x minus 2. And then graphing G1 on the CAS calculator, we obtain the following. We can see that G1 is that curve there. It's got a horizontal asymptote at y=2. That is a general graph of G sub k, either 2e to the power kx minus 2 in this sub-question there. And with that somewhat rough graph, it's going to make it easier for us to answer this question. Now, in the question, they talk about G sub k and G subscript k inverse. Well, now we're going to find, now that we found what G sub k graph roughly looks like, now we can also graph G sub k inverse by reflecting G sub k into the line y=x. So the black curve is the G sub k graph that we just got, and we obtain the inverse of G sub k by reflecting G sub k into the line y=x. And you end up with that blue curve there. And that blue curve there is G sub k inverse function, which we saw earlier on. So they're the two graphs that they mentioned in the question. Now, what's the other thing that they mentioned in the question? Well, they mentioned the following. In the question, they mentioned that you got the graph G sub k shown as a black curve here, and you got the graph G sub k inverse shown by the blue curve. Now, in the question, they say that if you go to the graph G sub k, which is that black curve there, and you go to x=0, and at x=0, you draw a black tangent line, you end up with that black tangent line there, which they call, in the question, L subject 1. L subject 1 is a tangent line of G sub k at the origin x=0. Also in the question, they mention that if you go to the inverse function of gk, which is the blue curve here, and you go to x=0, and at x=0, you draw a blue tangent line, you end up with that blue tangent line there, which is L subject 2. And according to the question, that L subject 2 is the tangent line of G subject k inverse function at origin at x=0. Now, what the question is asking is this: what will be the value of k, that k and that k, when the angle between that tangent line L1 and that tangent line L2 is 30 degrees? How do you find the k in such a situation? Well, you take the following approach. The question wants us to find the value of k so that the above mentioned angle of 30 degrees is obtained. To do this, we can take the following approach, as I say in the red writing there. We know with what we just said here, that that's 30 degrees. But we also know that originally we had that black curve there, and then we found the inverse of the black curve by reflecting the black curve into the broken green line y=x to get that blue curve. So once you understand that, then it should be relatively clear to understand the following: that to get that inverse function shown by that blue curve, we're going to reflect that black curve, GK, into the line y equals x. When you reflect that black curve, GK, in the line y equals x, then it goes to the other side. So when you reflect, for example, that point on the black GK curve into the line y equals x, it will have an equal distance on the other side. Now, because that distance from that curve to that line y equals x equals that distance from that line to that curve there, then you can understand that the angles here will be halved. And therefore, as a result, because from here to here it's 30 degrees, then the angular distance from here to here will be half as much. It will be 30 degrees divided by 2, 15 degrees, and that will be 15 degrees. Also, the next thing that we got to understand is that the line y equals x cuts the first quadrant in half. And the first quadrant is 90 degrees. What's half of 90 degrees? 45 degrees. So therefore, the angle between the x-axis to the line y equals x is 45 degrees. And because that's 15 degrees, then we can conclude that the angle from the x-axis to line L2 will be 45 degrees minus 15 degrees. It will be 30 degrees. So therefore, that will be 30 degrees. So the angle between the x direction of the x-axis and the line L2 would be 30 degrees. And like I say here, step 3, as a result, the above question gets simplified to the following. So as a result of these last couple of observations, we can simplify the question to the following. That we can just look at the blue curve, which is the GK inverse function, and the blue tangent line L2, L2. We know that the angle between the x-axis and the blue tangent line is 30 degrees. So the angle between the x-axis and the blue tangent line is 30 degrees. Now, from that, we can clearly see the following, that the gradient of the blue curve G subject K inverse function is equal to the gradient of the blue tangent line L2 at x equals 0. Now, using the fact that you should know that the gradient of a line is always equal to tan theta, then we obtain the following. What's the shorthand professional way of saying gradient of curve? It's to say derivative of G subject K inverse x at x equals 0 is equal to gradient of tangent line at x equals 0. And the other way of saying gradient of tangent line is a tan theta at x equals 0. Now, derivative of GK inverse function x at x equals 0 is equal to what's tan theta? What's tan theta at x equals 0? It's 30 degrees. That is, the gradient of the blue tangent line at x equals 0 equals tan theta, tan 30 degrees. Derivative of GK inverse function at x equals 0 is equal to tan 30 degrees is 1/3. Now, you can work out this part on the CAS calculator. by using the derivative at a point function on your CAS calculator by typing in, of course, the following. That's the equation GK inverse function, which is 1 on K times ln x plus 2 on 2 at x equals 0, at x equals 0. Press enter, and the answer will be 1 on 2K. And therefore, the above becomes the following. So therefore, like I say here, therefore, the above becomes the following. The derivative of inverse function K at x equals 0 is equal to 1 root 3. We just worked out on the CAS calculator that the derivative of GK inverse function at x equals 0 is 1 on K, which is equal to 1 root 3. And then you can match up the two fractions, and it comes out to 2K equals root 3. Get K by itself, root 3 on 2. So K equals root 3 on 2. So we found 1K value. But we need to find the second K value. The way we find the second K value is to consider L1, the tangent line L1, the tangent line of GK at the origin. And we take the following approach. We saw from the graph that we saw earlier on the following situation. That's the black curve GK, and the inverse of the GK curve is the blue curve GK inverse. And for the black curve GK, they had tangent line L1, and for the blue curve GK inverse, they had the tangent line L2. Now, like we say here, to find the second K value, we've got to consider the black tangent line L1 in the following way. We know from our earlier calculation that the angle between the x-axis and the blue line L2 is 30 degrees, and the angle between L2 and L1 is 30 degrees. So therefore, the total red angle between the x-axis and the black line L1 must be 30 degrees plus 30 degrees, 60 degrees. So therefore, the angular distance between the x-axis and the black tangent line will be, and the black tangent line L1 will be 60 degrees. So from that, we do the following as stated here in red. From the above diagram, we can see that the question can be simplified to the following. We got the black curve GK, we got black curve GK, and we got the black tangent line, which is a tangent to the black curve GK L1, and the angular distance between the x-axis and the black tangent line L1 is 60 degrees. Now, from that, we can say the following, that the gradient of the black curve GK at x equals 0 must be equal to the gradient of the black tangent line L1 at x equals 0. Again, using the fact that the gradient of a line equals tan theta, we obtain the following. We obtain the following. that the gradient of the tangent line at x equals 0 will be equal to tan theta at x equals 0. So therefore, what's the shorthand way of saying gradient of curve? Is a derivative of g subject kx at x equals 0 equal to gradient of tangent line L1 at x equals 0, which is tan theta, which ends up being tan 60 degrees. And then we go on to say derivative of gk at x equals 0 is equal to tan 60 degrees, which is root 3. Now we can work out this part on the CAS calculator. That is, on the CAS calculator, we can work out the derivative of gk at x equals 0. So by using derivative at a point function on the CAS calculator. So on the CAS calculator, you just type in the gk function, which is 2e to the power of k times x. Don't forget to put that times, or else the calculator can get a bit confused. Minus 2 at x equals 0. And then press enter, and you get the answer being 2k. Therefore, the above becomes the following. The derivative of gk x at x equals 0 equals root 3. And as we just worked out, the derivative of gk at x equals 0, according to the CAS calculator, is 2k. And that's equal to root 3. Get k by itself, and k equals root 3 on 2. Now, we can see here that we got the same k value as before. As I say here in red, this k value is the same k value that we obtained earlier on. So how do we obtain the second k value? We obtain the second k value by taking the following approach. We know from earlier calculations that the derivative of gk inverse function at x equals 0 is equal to 1 root 3. We also know from earlier calculations that the derivative of gk at x equals 0 is equal to root 3. Now, if we look at the graph that we had earlier on, we would see the following. That we would see that at x equals 0, that's a black curve, gk, that's a blue curve, gk inverse. We would see that at x equals 0, the derivative of gk inverse function at x equals 0 will be equal to the derivative of gk at x equals 0. Also, so as a result, we can say that at x equals 0, in this particular case, we can say that the derivative of gk inverse function at x equals 0 will be equal to the derivative of gk at x equals 0. And when you look at the earlier calculations that we had before, you can see that the derivative of gk at x equals 0 is equal to root 3. Okay. You can see again that the derivative of gk at x equals 0 is equal to root 3. Now, as you can see, in this question, we have already matched up these two. Now we need to match up these two. So we match up these two and we get derivative of GK inverse at x equal to 0, derivative of GK inverse at x equal to 0 is equal to root 3. Now, from our earlier calculation, according to our CAS calculator, the derivative of GK inverse function at x equal to 0 was 1 on 2k, and that's equal to root 3. So we're going to find what k is, all right? So you're going to get k by itself. So you can use a shortcut, interchange these two, and you get it to 1 root 3 equal to 2k, and get k by itself, divide by 2, and you get k equals 1 on 2 root 3. And this was the second k value. So therefore, by putting the two different k values together that we obtained, we first got k equals root 3 on 2, and just now we got k equal to 1 on 2 root 3. And by doing that, we've answered fully question H. Now we move on to question 4i. What is question 4i about? Question 4i. Question 4i. Let P be the value of k for which G subject k equals G subject k inverse has only one solution. Find P. I repeat, question 4i says, let P be the value of k for which G subject k equals G subject k inverse x has only one solution. Part 1, find P. Well, they're talking about GK equal to GK inverse. And they want us to find the K so that this has one X solution. How do you do that? Well, we saw earlier on that GK is 2 e to the power of kx minus 2. That's equal to GK inverse we saw earlier on was equal to 1 on k log e x plus 2 on 2. Now, for this whole equation to have one x solution, there must be only one intersection point between this graph and this graph. This occurs in the graph that we saw in the previous sub-question, which was the following graph, which was this graph here that we've seen now a number of times. In this graph here, clearly there is just one intersection point between the black curve GK and the blue curve GK inverse. That is, there is only one solution between the GK black curve and the blue GK inverse, which is what they want you to answer in this question. So in the final analysis, in this sub-question, they're talking about this graph here, which is the graph with one intersection point there. So knowing that, how do you go on and finish off this sub-question here? Well, by taking the following approach. We know from our earlier calculations that the derivative of the black GK curve at x equals 0 was equal to root 3, highlighted with a pink highlighter here. And we know also from our earlier calculations that the derivative of GK inverse which is the blue curve at x equals 0, was equal to 1 root 3. Now, when we got the situation where there's only one intersection point between the black curve GK and the blue curve GK inverse, which is what this sub-question is on about, then clearly that black gradient there must be equal to that blue gradient there at equals 0. So therefore we can say the following, that, like I say here in red, also by looking at the above graph, we can see that at x equals 0, the derivative of GK at x equals 0 is equal to the derivative of GK inverse at x equals 0. Now, from our earlier calculations, we saw that the derivative of GK at x equals 0 equals 2k. And we also saw that the derivative of GK inverse at x equals 0 is equal to 1 on 2k. So from the above graph, we can see that clearly at x equals 0, the derivative of GK at x equals 0 is equal to the derivative of GK inverse at x equals 0. So from the above, we end up with the following, that the derivative of GK at x equals 0 is 2k, and that's equal to the derivative of GK inverse at x equals 0 is 1 on 2k. And at which point, all you're going to do is find k for this equation here. Okay, multiply both sides by 2k. And when you add 2k times 2k is 4k squared. That's equal to 1. And find k, get k by itself. K divided by 4. Get rid of that square by doing the opposite. Opposite to square is positive, negative square root both sides. And you end up with k equals plus or minus a half. Now, k can be positive or negative. Are both acceptable in this question? Well, in the question, they clearly say that k is an element of the positive real numbers. So therefore, k can only be a half. So therefore, p equals a half. And by doing that, we've answered this sub-question here. Now we go to the next sub-question, which is sub-question question 4, part 2. Let AK be the area bounded by the graphs of G subject K and G subject K inverse for all K greater than P. State the smallest value of B such that AK is less than B. How do you do such a question? Well, we know from the previous question that when K equals P equals a half, that is when K equals a half and P equals one half, there will be just one intersection point as shown in the following graph. So we know from our previous sub-question, which was question 4i part 1, that when K equals a half and P equals a half, we're going to have just one intersection point between the black curve GK and the blue curve GK inverse. Now, if when K becomes bigger than P, That is, when k becomes bigger than a half, for example, when k is 8, the following happens. That is, on the CAS calculator, if you put k equals to 8 into gk equals 2e to the power of kx minus 2, you're going to end up with g8 equal to 2e to the power of 8x minus 2. If you graph it on the CAS calculator, it's going to give you that black curve there with the horizontal asymptote at y equal to 2. And if you put k equal to 8 into gk inverse equals 1 on k log e x plus 2 on 2, you end up with g8 inverse equal to 1/8 log e x plus 2 on 2. If you graph that blue equation there into your CAS calculator, you end up with that blue curve there. And in such a situation, you will see that now there will be two intersection points between the black curve GK or G8 and the blue curve G8 inverse. And in this question, they're talking about the orange area between the blue curve G8, the black curve G8 and the blue curve G8 inverse. Now, if you now further increase the K value, to, for example, K equals 30, then you're going to end up with GK equal to 2EK x minus 2 becomes G30 equal to 2E to the power of 30x minus 2. And you're going to end with, and when you graph G30 equal to 2E to the power of 30x minus 2 on your CAS calculator, it's going to give you that black curve there with the same horizontal asymptote at y equal to 2, shown by that black broken horizontal line. And when you put k equals 30 into gk inverse function equal to 1 on k log e x plus 2 on 2, it's going to get it to g30 inverse function equal to 1 on 30 log e x plus 2 on 2. And when you graph g30 inverse equal to 1 on 30 log e x plus 2 on 2 on the CAS calculator, it's going to give you that blue curve there. And it's going, and that blue curve will have a vertical asymptote at x equal to 2, which is not surprising because after all, they are inverses. So therefore, the original black curve has got a black asymptote at y equal to 2. So understandably, its inverse will have a vertical asymptote at x equals -2. Again, every time you want to find the inverse, you interchange the x and y's. Now, again, in this question, they're talking about working out in some way the orange area between the original function g30 and its inverse function g sub 30 inverse function. They're talking about that orange area there. Now, as you can see, as you increase the value of k from k equals 8 to k equals 30, the orange area increases. And from that, we can say the following, as I say here. And please note also that here, because of the x-axis, and that's at y equal to 2, then the distance from C to E is 2. And also, because that's the y-axis, and that is that's the vertical asymptote at x equal to 2, then the horizontal distance here is 2. So that distance there is 2, and that distance there is 2. clearly the shape VCDE is a square. So by saying that, we can go on to say the following. We can see that the orange area has become bigger. This orange area will always be within the square VCDE, no matter how big K is. And as I was saying, as K gets bigger, for example, K equals 100 and bigger, for example, K equals 1000, the orange area will get bigger and bigger. But this orange area will always be contained within the square VCDE. So no matter how big K is, the orange area will always be less than the area of the square VCDE. That is, the area of the orange area is less than the area of the square VCDE. Now, the question says quite clearly that the area of the orange area is AK. So therefore, now let's find the area of the square BCD. Now, like I was saying before, the square BCDE is formed by the vertical asymptote x equals -2 and by the horizontal asymptote y equals -2. So as a result, we say the following, that the distance, like I was saying to you before, from B to C is 2 units. That length there is 2 units. And like I was saying to you before, the distance from C to E is 2 units. That is, the length is 2 units. The length is 2 units. So from the above graph, we can see that the area of square BCDE is equal to the area of any square, which is length times length. So therefore, the area of the square BCDE is equal to the length of the square, which is 2, times the length, the other length of the square, which is 2. So therefore, the area of the square BCDE is equal to 2 times 2, 4 units squared. So therefore, we now know the area of the square BCDE equals 4 units squared. So therefore, by putting together all of the above, we obtain the following. That like we said before, it is always going to be the case that, like we said before on an earlier page, which was on this earlier page here, that it is always going to be the case that the area of the orange area will always be less than the area of the square BCDE. Now, and like we said before, the area of the orange area, according to the question, equals AK, and that will be less than what? Well, the area of the square BCD is equal to 4 units, and so therefore AK is less than 4, And the question says quite clearly that AK is less than B. They match up perfectly. So therefore, B must be 4. So therefore, B equals 4. And as a result, we have fully answered the question, and we have fully answered the whole of the extended response question 4.